Okay, so why should you guys care about this? What does all of this mean? I told you I was going to try and tell you why you should care about these indirect effects. And so we can play a little game where we can ask the question, what happens if we cause high or low predation guppies to have a very small change in herbivory? Okay? And then what we can do is we can predict, use the model to predict what the change in the algal biomass should be given that change. Then we can make the assumption, which is the very reasonable assumption, that less algae in the environment selects through natural selection for decreased herbivory. And you can see that the key to understanding this here is this equation right here, which is a series of partial differential equations, but really all it says is that the total net effect of algae, or the direction that algae should change, is a function of both the direct effect due to changes in herbivory, and then also the indirect effect. And so these are those derivatives of the direct and indirect effects for both high and low predation guppies that we can calculate from the model fairly easily. And the thing to notice, although the indirect effects are these dashed lines and the direct effects, derivatives of the direct effects, are these solid lines, the thing to really notice from this graph is not that they're flipped between low and high predation, but rather in each case, the derivative of the indirect effect is larger in absolute magnitude than the direct effect. And what that tells you is that if you plug those into this equation here, that the sign of the indirect effect will always determine the dynamics of what's going to happen to algae. Because it's always larger, it'll dominate this equation. And so in order to understand how algal biomass changes as a function of evolution, you must know something about the indirect effects. So how would this play out under some scenarios? So the first scenario we can imagine is that what if high predation guppies, all else being equal, become less herbivorous for some reason? Well, we can look to understand how algal biomass changes, we can look to the derivatives. And if you remember from the previous graph, the derivative of the indirect effect for high predation guppies is very large and negative, and the derivative of the direct effect is small and positive. And so, then that means that the total change in the net, dominated by the indirect effects, will push this difference between high and low predation guppies downwards. So the difference between them will become less, which means that the absolute algal standing stocks for high predation channels would go down. So we'd get less algal biomass. And less algal biomass selects for decreased herbivory, which then should select for high predation guppies being even less herbivorous. And so this would be a case of runaway selection through this eco-evo feedback. If we had only considered the direct effects in this case, we would actually get the opposite result. You would see that algal biomass, instead of decreasing, would increase, which would then select, more algae should select for increased herbivory, and then HP guppies would be selected to be more herbivorous. And this now would be a case of balancing selection. So we get very different patterns of selection, whether or not we consider the direct effect only or the direct and indirect effects of evolutionary change. So I just want to leave you guys with a few take-home messages. The first is that although the total indirect ecological effect of adaptation is small compared to the direct effect, that indirect effect is comprised of many constituent and very large indirect effects that effectively cancel each other. Second, that it's the derivative of the effects that determine how algal biomass responds to evolutionary changes, not the standing stocks. And you can't infer how those will change based off of what you're observing. Finally, because the derivative of these indirect effects, in guppies at least, are larger than the direct effects, and they dominate the predictions of how ecological and evolutionary change. And then finally, the direction of the predictions depend on whether we consider either the direct or the direct and indirect effects. with that, I'll take questions if there's any. And thank you very much again for the opportunity to speak.